VLSos here. This is a video lesson on factors. We'll define what a factor is. The word factor can have a couple of important meanings. A factor is a part of a product. For example, and we have to remember that a product is a multiplication problem or the result of multiplying. So in this simple example, 2 times 3 equals 6. We could point to the 6 and call that a product because the 6 came from multiplication. And the parts of the multiplication, the 2 and the 3, are each factors. 6 is the product of multiplying the factors 2 and 3. Factor can also be an instruction. An instruction to separate a product into factors. For example, we could be instructed to factor and be given a number to factor. We want to think of 24 as a product and think about what factors that we would multiply to get 24. There are many things that we could think of. 24 has lots of factors, meaning it can be divided evenly by several different numbers. But if we're asked to factor, we could say 24 is equal to 4 times 6. And 4 and 6 are factors of 24. When factoring, we need to be aware of prime numbers. A prime number is a number, has to be greater than 1. There are no prime numbers that are negative or 0 or 1. A prime number is a number greater than 1 that has no integer factors other than 1 and itself. Every number can be divided by 1, and every number can be divided evenly by itself. So when we're considering prime numbers, we're considering those numbers that can't be divided evenly by anything other than 1 in itself. Prime numbers are important when we are asked to factor, like factor 13. If we're asked to factor 13, we're looking for numbers, integers, that divide 13 evenly. So we can show 13 as a product of those factors. We can find many numbers that divide 24, like 2 and 4, 6, 8, 12. But looking for numbers that divide 13, we're not going to find any. 13 is prime. The only way to express 13 as a product is to use its only factors, 1 and itself. And this isn't helpful because we didn't get anywhere. Our product includes the number itself. So we didn't find any parts to 13. We didn't break 13 down into different factors. So we could say, can't, 13 is prime. Now, sometimes we want to find all of the factors of a number. We could look for the prime factorization of a number. And that simply means to factor a number completely. We didn't do that when we factored 24. We expressed it as the product of 4 and 6, but we could have gone further because we could factor 4 and we can factor 6. So let's provide another example in which the instruction was to factor completely the number 24. I'm going to make a tree to organize factoring 24. I'm going to make branches and start with what I already know are two factors of 24, 4 and 6. 4 times 6 make 24. But 4 can be factored further because I can express 4 as the product of 2 and 2. And 6 is not prime. I can express 6 as the product of 2 and 3. Now I need to consider these numbers and factor them further. But with 2, I've reached a prime number. 2 can only be divided by 1 in itself, so I can't factor it anymore. 3 is also a prime number. I can't factor it anymore. I can stop with these 2s and 3s. So I have factored 24 completely, and the result is the prime factorization. The prime factorization of 24 is equal to the product of all of these factors. 2 times 2 times 2 times 3 will equal 24. So it's a factorization. We broke it down into a product, and all of the numbers that are the final result, all of these factors are prime numbers. That's why we call it the prime factorization. If these numbers weren't prime, then we could go further to find more factors. But we've stopped there. All of these numbers are prime.